respond in the chat box. Yeah, thank you, Amog, for that thumb. Okay, nice. Okay, as this video is recording, this session is recording. So I need your interactiveness during this learning course. Okay, so yesterday we discussed about uh, collision. So hopefully you all can remember collision occurs when two hash functions maps two different keys to the same location. Obviously, two records cannot be stored in the same location. So therefore, we need some method to solve this problem of collision. So um we call this solving technique as collision resolution technique. And of course, there are two most popular methods uh, of resolving collisions. So one is open addressing, another one is chaining. Yesterday we have seen this chaining. Okay. So chaining where if collision occurs, chain is created. So a chain is created like this. Chain is created, and we have discussed. We had discussed. So you can see the example as we are inserting the elements. If you have the elements with the same index generated from hash function, then the chain is created using linked list. So if there is no element with that particular index, so what happens? It will be null. So unnecessarily you are storing null. So in order to avoid this storing of null, uh, so what we do is we will make use of another technique called open addressing. In open addressing, we discussed about linear probing. So linear probing, what it will do? If there is a collision, it will check the next position. If there is a collision, it will check the next position. So whichever the position is available, it will occupy. So this is the code. This is the formula that we have to use. If you want to find for a key k, if you want to find the hashing of key k, so you had to make use of I. I is a probe number, so that will be starting initially from 0 and it will go up to m minus 1. M is nothing but it is the total size of the hash table. So you initially do hashing of a key by using k mod, you can see by using k mod m. So h dash of k is you can certainly calculate it by using k mod m, where k is the key. So if there is a collision, what you do, I will increase to the next location. I will increase to the next location. Next location, it will store. So yesterday we have taken this example. So if there is a collision, so what happens? It used to go to the next elements. So you can see this is how the techniques are being followed. So yesterday we discussed the same concept. So 92, 101, 101 initial position is uh, 1. So that is P of 2, the table of 2, which is not available. So what it will do, it will probe to the next cell, next cell, next cell, next cell, next cell, next cell, and finally it is available here. So there it is going to be stored. So you can see similarly it's available in the next cell. So that's how. So it is probing the next, and finally it is storing. That is available. So with this technique, we can avoid null values. So that's the concept. So second topic that under our discussion is quadratic probing. So what is exactly quadratic probing? Here we use two constants, C1 and C2, along with the probing number I. So we use C1 and C2. Remember one thing, probing number I will get the value 1 with get the value 2 with get the value 3, 4, 5 if there are collisions. If there is no collision, I value remains 0. So that is the first thing that you should note. Hopefully all of you are noting down. Uh, all of you are noting down. This is the quadratic probing. Why it is called a quadratic probing? You are multiplying with I some constant. You are multiplying I square with constant. It is like a quadratic equation. That's why it is called quadratic probing. So, where C1 and C2 are some constants. Look at the example given here in this particular line. Consider a hash table of size 10. So M is 10. Using quadratic probing, insert the following keys: 72, 27, 36, 24, 63, 81, and 101. So you can certainly make the insertion into the table. And you observe here, we have C1 is equal to 1, C2 is equal to 3. So they are constants. So these constants will get life when I gets the value 1, I gets the value 2, I gets the value 3. So if I is 0, even constants will not be used to calculate the hashing. So when I will be 0, that is prob number will be 0 when there is no collision. When there is no collision, then this is the thing. Now, take the first element. The first element 72. 72 modulus, so 72 modulus 10. So 2. So 2 places empty, automatically it will store. So you can see 72, there is no problem, it will be stored. Similarly, 27, yes, it is 7th position is empty, it will store. Similarly, 36, yes, it will be stored. 24, 4th position is stored. 81 is stored. Right. So without collision, they are stored, and even 63, it is stored. So now up to here, 71, 27, 36, 24, and 63 stored, even 81 stored. Now we have 101. 101, we will look into the next. Look at here, we have 101. For that, we need to calculate. Remember, when we calculate, so for the first time, 101 modulus 10 plus 0, 0, 0. So modulus 10. So what happens? 101 is, reminder is 1. 1 modulus 10 is 1. So 1 is already occupied. There is a collision. So what happens? Your quadratic probing value I gets, you have to apply. When there is a collision, I value automatically incremented to 1. So when it is incremented to 1, so there is a collision, it is incremented to 1. So what happens? Look at here. 101 mod 10 plus 1 into 1. C1 value is 1. You can see C1 value is 1. And C2 value is 3. C2 value is 3. You can see there. So you multiply 1 into 1 and C2 value 3 into 1 square. So altogether it becomes this 101 module 10 is 1. So 1 plus 1 is 2. 2 plus 3 is 5. So 5 modulus 10 is 5. So look at the 5. Yes, it is available. Yes, it is available. Yes, it is available. You can store it. So you can store it. So that is the technique. That is the technique that been followed here. Even that is occupied, then what I value gets incremented to 2. And you should have applied this 2 here, I into 2 square. So you should have done it. And finally, you should have calculated it. So that's the concept you should understand and learn. Now, the next technique, we have seen linear probing, we later quadratic probing, then double hashing. Double hashing is the next technique that we need to understand. So what is exactly double hashing? In double hashing, we use two hash functions. So far, whatever we have seen, linear probing or quadratic probing, so we could able to see only one hash function. Now, we have two hash functions rather than single function. And the hash function in the case of double hashing certainly can be given like this. So you have h1 of k, I into h2 of k. So h1 of k will be working and h2 of k will work only in case of collision. Sir, how can you say that? Remember, I value will be 0 for initial value. If there is a collision, I gets incremented. So when I gets incremented, so automatically the second hashing function gets its importance, and it will be added to the first hashing function, and it will find the next location. So if there is collision, again I value increments to 2, I value increments to 3, I value increments to 4, like that it proceeds further. You can see here where m is the size of the hash table. H1 of k and H2 of k are two hash functions. So H1 of k is written like usual, k mod m, and H2 of k, it is calculated with m dash. So you can see h2 of k, it's another hashing function with m dash. M dash is nothing but another number. Usually it is either m minus 1 or m minus 2. So that is left to the designer or the programmer. You can choose any one, m minus 1 or m minus 2. And I is the prob number. We already know I is the prob number. So that varies from 0 to m minus 1. So m dash is nothing but, you can choose the lesser value than m. We can choose either m dash as m minus 1 or m minus 2. That's in our hand. Okay, now take one example. So hope you have already noted this. This is very, very important, hash function. So you have two hash functions. One is h1, another one is h2. So h1 and h2, you should note it down. Now, take the example. consider the hash table of size 10. Using double hashing, insert the keys 72, 27, 36, 24, 63, 81, 92, and 101. The same values. And H1 is equal to K mod 10, and H2 I have taken it as K mod 8. Because, you know, M dash, I can certainly take it either M minus 1 or M minus 2. Better I take M minus 2. So that is that. Now, initially 10, okay, so all are empty. Now we apply this 72, 72, since it is the first element, you get 10 mod 72 mod 10 plus 0, I value is 0, 0 multiplied by anything is 0. So you get 2 here, 2 mod 10 is always 2. So second position is always available. So it will store 72 in its second position. So it is done. It is done. So the same way calculated, it is done. It is stored. 72 is stored. So later, the next element, 27. 27 also same. You get 7. Seventh position is available. So it will store. Similarly, 36. 36 is also available. Stored. 24. 4 and 63. Third position. 24 is available. 63 available. 81 available. So they are stored. 24, 63 and 81 are stored respectively. Done. Now what we have is 92 and 101. Now let us take this is the hash table status that we have taken from previous slide. So now we have to insert 92. So definitely 92 we get the value 2, index number 2, which is already occupied by 72. So there is a collision. Definitely there is a collision. So collision. So obviously you cannot store the value 92 in second position. So what we do here is we had to apply double hashing technique. So double hashing technique, so automatically our probe value, I value, which was earlier 0, now I value will get increased to 1. So I becomes 1 now. So I value becomes 1 now, and you can see. So just clear the things. Just see 92 we have written here 92 mod 10, 1 into 92 mod 8. So when you make a 92 mod 8, we get 4. We get 4. And 92 mod 10 is 2. So this 4 is multiplied with the I value, that is 1. So 4 into 1 is 4. 4 plus 2 is 6. So sixth position, sixth position is also occupied. So what happens? I value automatically the sixth value, which is already occupied. So what happens? I gets increased now. I get increased. So I will increase to 2. So obviously I is increased to 2. So look at here, I value is increased to 2. So you do the same thing. 92 mod 10, 2 into 92 mod 8. So that is we get 2. So 92 mod 10 is 2. 2 into that is 92 mod 8 is 4. 2 into 4 is 8. 8 plus 2, 10. So 10 mod 10, we get 10 mod 10 is equal to 0. So 0th location is available. Wow. So 92 gets stored in this position 0. Similarly, 101 also. 101, which is not available with respect to uh, 81. Later you have to apply, and finally you can certainly get the value, its location, and it will store. The next technique we call it as rehashing. So far we have seen linear probing. This is collision resolution technique, and we have quadratic probing. Then we discussed about double hashing. The last method is rehashing. What is exactly rehashing? So when hash table almost becomes full, so I think you remember when we were talking about dynamic stack or dynamic queue. So when stack or the queue is almost is about to full, so automatically what happens? Their size, earlier their size was 5, so it used to double. It used to double, and the size should increase to 10. So the size used to double the original size. So when the size becomes double, what happens? M value, earlier it was 5. Now after becoming double, M value would become 10. So what I have to do? I have to rehash. So since the M value is changed, I have to rehash the entire, I have to calculate rehashing. So for that reason, so what we do? For that reason, we will do hashing, rehashing. So that's what it is given here. So when hash table becomes nearly full, the number of collisions almost increases, thereby degrading the performance of insertion and searching operation. In such cases, a better option is to create a new hash table with a double size of the original hash table. So you have to double the size of the original hash table. So what happens when you do so? All entries in the original hash table will then have to be moved to new hash table. So what happens? This is done by each entry computing new hash value, because M value changes. M value changes. As the M value changes, so definitely you have to calculate the rehashing, and you have to do. So here is one example. True, rehashing seems a simple process. It's quite expensive. So must therefore not be done so frequently. So consider a hash table of size 10 given below. Hash function looks like this. So after it becomes double almost, so what happens? We have to go for it. So look at here. So this is the modulus 5. Whenever we do modulus 5, so these are the locations that we have got. So when it is about to fill, there is only one element left. So in that case, automatically the size becomes double. So size becomes double. When size becomes double, so what happens? We have to calculate again hashing for 26, 31, and 43 and 17. So when we calculate them, so since the M value changes, we calculate them, and they got distributed across the hash table. So this technique, we call it as rehashing. Rehashing is quite simple. So you have to do once again the hashing. So, and last topic for today. So after this, we are going to discuss about lab program 5B. So that is totally based on hashing technique. Okay. So you can see here, this is a static hashing is a technique in which resultant bucket size remains same. So there is no change in the bucket size. So far, we have seen the linear probing, quadratic probing, and uh, double hashing. So these are all, they all have the fixed uh, size. So there is no change in the bucket size. Bucket size is nothing but the hash table size. So they are called static hashing. They are called static hashing. And dynamic hashing is a technique in which bucket size is not fixed. And of course, that can increase or that can decrease, grow and shrink. A typical example is what we have seen in the previous, that is dynamic hashing, that is rehashing, is extensible hashing technique. So it is a technique which handles a large amount of data. So that data is to be placed in the hash table by extracting certain number of bits. So totally, it is totally based on the number of bits, and of course, you can see uh, it is extensible hashing, referring to the size of the directory or the elements that are placed in the bucket. So that is the thing that you have to understand. And that's the concept. And of course, that's about hashing. Now, we will look into, that's about hashing. Your entire content related to hashing is done. So now, what I do, I will, talk about uh, the technique. I will talk about the technique for that is lab program. So I'll talk about your lab program 2B, 5B, talks about you have given n file of n employees records uh, with a set of keys, k keys, that is 4-digit number, record number, which uniquely determine the records of the file. So in the file, it has to be assumed. And assume that file maintains a memory by hash table uh, of size m memory locations with L set of memory addresses, that is 2 digits. It will maintain 2 digits of locations in hash table. Let the keys in K and address in L are integers, and design and develop a C program uses a hash function. uh, H of H is nothing but key of L, so that will find the location L. So H of K you can certainly calculate based on K mod M. So that is the first method, which is called reminder method, which is also called division method, and implement the hash technique to map a given key K to the address space L, and if any collision is there, you have to resolve this collision using linear probing. So make linear probing, and so you can just certainly do the things. So you can certainly calculate the technique linear probing. So that is the concept that you have to understand. It is a concept that you have to understand here. And now look at the first line. Hash include stdio.h, hash include uh, stdlib.h. So now, so remember in C programming, if you want to if you want to write a text file, so you make use of file pointers. You can see here, file pointer, FP, file pointer. It is a file pointer through which you can do all the file operations. You can do all the file operations. So file pointer FP is a pointer through which we can do all the file operations. And we have a next line, you can see struct employee. So we have a name, key is nothing but their ID or whatever it is. Salary, these are the three fields that we are using. So key and salary are integers, name is a character, and we have 20 employees. So since employees are 20, so we will make use of the m value. We will make use of m value as 20. M value is 20. So we understand m value is 20. So you can certainly understand. So uh, n is an integer, and m is an integer. Similarly, integer ht is nothing but it is star ht, so it is an array, and index is the number location that it is going to be generating. And initially count will be 0. So let us come back to insert function later. So come to main function. Look at here main function. In main function, we have integer I, that is to take the count of employees. So it is a looping statement. We clear the screen, enter the number of employees, you take n, and the n value percentage d and ampersand n, and enter 2-digit memory locations for hash table. So you can certainly take the memory locations, that is the size, that is the size of m, you can certainly take it. So based on the size m, so you allocate the hash table ht is equal to dynamically you create. So we have taken initially 20. If user changes the value m, so obviously, so it has to be changed. It has to be changed. So that is a concept here. We have to understand. So based on the m value, whatever user enters here, so the m value, whatever user enters here, so based on that, what happens? We can certainly calculate. We can certainly calculate the size. We can certainly do the size. We find the allocate the memory for your HT. So we can certainly allocate. So 1 second, some students are messaging me. They cannot see the screen. So I'll do one thing. I'll reshare. I'll stop sharing and I'll reshare. 1 second. I reshare. Yeah. Entire screen. Yeah. Yeah. I think hopefully you can see now. Somebody please respond. Are you able to see my screen? Please respond. Uh, can you see my
Yes, sir.
screen? Yeah, thank you. Thank you. Thank you. Yeah. I was just talking about this particular uh, technique, that is hashing. So once it is done, so you can certainly allocate the memory. If m is known, so we can allocate the memory. So now we use um, we use for loop for I is equal to 0, I less than m, I plus plus. So we make all ht locations. Ht of I is equal to -1, -1, -1, -1, -1. So we just make it empty, hash table empty. So that is done. So And after that, we open a file called program1.txt or program5a.txt or whatever it is. It is a file that is opened in write mode. Write mode means you can write the contents into the, and it is done through your file pointer. File pointer we have seen in the earlier, it is created for the sake of opening and performing the operations. And immediately after that, what you are doing, you are displaying a message, printf enter 4-digit key and name and salary, 4 digits. So key, that is employee ID, should be 4 digits. K and n employees. N employees, that is uh, you have already taken the n value, n employees. So you can certainly take for I is equal to 0, I less than n, I plus plus, you take the employees. So employee I of key, you read, employee I dot name, employee I dot salary, you read, and once it is written, you write fprintf. Fprintf means write the contents not on screen. Printf means it will print on the screen. Fprintf, print the contents of this particular string on the file. So into the file. So the file pointer fp is written here, and what is to be written? First %d is key, %s that is name, %d the salary. So all these things you are supposed to write. So this entire thing, you're handling the file, you are reading the contents from the user and writing into the file. So that is, and finally you close the file. That's the thing. So you write the contents. Now you open the file contents in read mode. You can see it is in R. R indicates it is read mode. So initially you write the contents into the file. You read the contents from the user and write it into file and close the file. After that, you open the file in read mode. So using file pointer. Now you have to read one record by record, and it has to be put into the hash table. So for that, what we are doing, for I is equal to 0, I less than n, and you're writing if count is equal to m. That means counter, you're using count. If it is m, then what happens? You say the hash table is full. So m is, so sorry, I was just, hash table is full, cannot insert the record into the hash table. So you can certainly write and you can certainly break and come out. So that is because we are using in a for loop, and we have to insert n records. So we are getting it. So after that, what you are doing is we are reading the contents. Scanf. So normal scanf, what we'll do, we'll scan from the keyboard. Scanf, you scan from the file. So what is the thing that you are scanning from the file? First employee key. That is, key is nothing but employee ID. You are reading it. Now you call insert function. Insert function that will go on to insert into the hash table. So you pass this employee, first employee of I to the key. So what happens? It will be inserting. It will be inserting. So in insert function, you look at insert function. We have written it before. Yeah, insert function. Look at insert function. So it is called linear probing we are doing. We know m value, we know the key, and we have to find the index. So index is equal to key modulus m. So if it is -1, ht of index, ht, that is hashing table of index, is -1, that is the indication that the cell is available. It is not storing any value. There is no collision. So immediately you can you can certainly, uh, if it is, if there is no collision, so it will be -1. So if it is not -1, then there is a collision. So you display immediately. If it is not collision, you display immediately collision detected for this, and you resolve using so index plus 1. So index plus 1 is nothing but linear probing. Linear probing, you check for the next cell. I value increases, the probe number increases, modulus m. So if that also it is not -1, that is it is not available, then increase index plus 1. Again, index is equal to index plus 1 modulus m. So calculate, detect and calculate, detect and calculate until you get free space, that is -1. So once you get -1, so once you get -1, so that means it is available for insertion. So what you do? HT of index is equal to key and count plus plus. So why we are using count? Just to understand how many elements we have inserted into the hash table. If there are the equal number of elements inserted, so that is the hash table size is, just imagine user has entered the hash table size is only 20, and all 20 employees are inserted. And if user wants to enter the 21st record, so what happens? It will throw an error. So that we have seen in the earlier part, So that's about the insertion. And when it comes to display, so what we are doing in display, so we are just starting integer I. If counter is equal to 0, that means hash table is empty. We are just returning without any display. If it is not 0, count is not 0, you just display printf. The hash table contents are for I is equal to 0, I is less than m is the total size of elements. The hash table contents are so and so. We are just displaying. So we are entirely displaying the hash table contents here. You can see hash table contents are displayed. So once it is displayed, it is closed. You can certainly close it. So that's the concept here. And the anticipated output, if I show anticipated output, so what you do, uh, you ask how many employees, 5 employees. You ask how many locations are, their M size, that is size of the hash table, 10. You can certainly give. Enter 4-digit key, that is ID, and name, salary. So you are entering, this is the ID, this is the key, this is the value, this is the salary, ID, name, salary, ID, name, salary for 5 records. 1, 2, 3, 4, 5. All 5 records it is done. So now for it has to be stored. Now everything has to be stored. So you understand there are 10 cells available. There are 10 cells available. So 0, 1, I'll just write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 8, 9 and of course 10. So 10 is anyhow it is the last cell, so we are not considering. So now look at here, first one, 4 ones, double one, double one. So modulus 10 is 1, so it will be stored here. So double one, double one, so it is stored here. So you can certainly think of stored, double one stored. Next element is 7689. So 7689 modulus 10 is 9. So here you can certainly store 7689. You can store directly. It is in the ninth place. Done. Next, double two double two. It is available in two double two double two is available. Done. Next, 2341. 2341. 2341. So its modulus 10 is 1. So it is having a collision. So what happens? It will check the next cell. Next cell is also not available. So next cell is also not available. It will go to the next cell. So probing, linear probing it is doing. So you can see the detection for 2341 is resolved using linear probing detection. For this 2342 resolved using linear probe, it is checking and it will be stored here. So 2341 is stored. Later the next one 2342. 2342, this is also not available. So 2342, it will check for linear probing. Next cell, no, it is not available. Next cell, it is available. Yes. 2342, yes, it is done. 2342 is done. So all the elements are done. Now here you have -1. So here also -1, here also -1, -1, -1. So you can see when you display them, when you display all these elements, so you can see when you display all these elements, so you can see uh, 0 is -1, 1 is 111, then 2 is double two double two, 3 is 2341, 4 is 2342. So 2342, and next cells are empty. You can see this is empty, this is empty, this is empty, this is empty. So 5 6 7 8 are empty, 5 6 7 8 are empty, and in ninth position you have 7 6 8 9. Yes, ninth position 7 6 8 9 you have stored. So this is the hash table that we are supposed to display. That's the program that you need to be aware of with respect to uh, 5B. So with this, we formally conclude the syllabus completion. Uh, thank you for being wonderful students throughout the semester. I thank each one of you for interacting with me in this regard. And if you have any doubts, so kindly don't hesitate to reach me for any kind of doubts or solutions. So I'll be happy to assist you. So that's all from today's session. Have a great weekend and enjoy your study holidays. Stay safe, work hard, get good Lawrence, good results. And your internals will start from 13th. So next Monday, it is starting from 13th. And the syllabus for internal is module 4 and module 5. So you need to prepare module 4 and module 5 for the internals. 3. So that's all. Please type in your USN in the chat box